Today we're going to be learning how to solve two-step equations with our note sheet. First we're going to talk about the different parts of an equation. On your notes you have 7x plus 15 equals 4. We know that this is an equation and not an expression because it has that equal sign. But there's also names for all of those different parts in the equation. Let's look at the number 7 in this equation. Number 7 is what is called the coefficient. That means that it's the number that's getting multiplied by the x. I like to call the coefficient the best friend, and you'll hear me say that throughout the video. The x is the variable. That's that letter that stands in for a mystery number that we'll be able to solve using our steps today. I like to think about the variable as me, and then that 15 is called a constant. That's just that number that's on its own. 15 is always the number 15, so we call it a constant. I like to call that just your normal friend, not a best friend, but still a friend. Now, when we're solving equations, we have one goal. We want to get that variable, and remember, that variable is usually a letter called, more often than not, it's the letter x, and we want to get the x alone. Well, how do we do that? Well, we're going to use inverse operations. And inverse operations is just a fancy word for opposites. So we're going to be using operations that are the opposite to get rid of different parts of our problem. For example, if we want to undo addition, we are going to use subtraction. If we want to undo subtraction, we're going to use addition. If we want to undo multiplication, we're going to use division. And if we want to undo division, we're going to use multiplication. So this chart is going to kind of help us to remember our different inverse operations. So let's look at the bottom of the screen here. It outlines our steps. The first thing we're going to do is circle that variable. Remember, variable is our vocabulary word for the letter x. This is what you want to keep. Then we're going to draw our railroad tracks, and that'll make sense once we see our first example. Then we're going to get rid of the addition and subtraction using inverse operations. Again, you can look at your chart here, but I want you to put a little star here and put friend. So first we're going to get rid of that regular old friend, and then step 3, we get rid of multiplication and division, and that is going to be our best friend. So go ahead and write that into your note sheet. Alright, let's take a look at our first example. This is the same equation that we've been looking at since the beginning. 7x plus 15 equals 4. So my very first step is to find out where that variable is. That variable is right up front, it's 7x. Then I'm adding 15 to it. Now I'm going to go ahead and draw those railroads. And now I'm going to be ready to start solving. Remember, my first thing that I'm trying to get rid of is that 15. That's my regular old friend. So to get rid of that 15, I'm going to look at that equation, or that operation that's getting done. We are adding, so I'm going to do the opposite, the inverse operation, and subtract 15. Now the reason that I drew my railroads is because I'm keeping the two different sides of my equation separate. So I'm going to also do the exact same thing on the other side of the equation, got to keep it balanced. I'm going to subtract 15 from both sides. Now when I subtracted 15, my adding 15 and my subtracting 15 made 0, but I still have that 7x. On my other side of my equation, I had 4, and then I subtracted 15, so now I'm left with negative 11. Now I'm ready to go ahead and get rid of that best friend. I still want to keep that variable, but to get rid of that 7, I have to think about what's getting done. Right now, since it's squished up together, it's getting multiplied, so I'm going to go ahead and divide both sides by 7, and that's going to give me x on the one side, so my 7's cancel out. And then on the other side, I have negative 11 over 7. And if I put that in the calculator, I can get a decimal, but a fraction is just as good. I'm just going to leave it like that. So now I know that x equals negative 11 sevenths. And I could go back and check that by putting negative 11 sevenths into my equation where x was, and then solving it out, and I would still get 4 on both sides. I'll show you that in the next example. Alright, let's take a look at this one. So now I have x over 3 minus 12 equals 6. Remember, my first step is always to find out where that variable is and draw those railroad tracks. I want to see railroad tracks on every single paper that you turn into me. So now I'm ready to get rid of the friend first and then the best friend. One way that I can help remember which one is the friend and which one is the best friend is your best friend is always going to be closer to you. This 3 right here is much closer to you, the variable, than the 12 is. So I know that if I have to send somebody home first, I'm going to get rid of that 12. I was subtracting that 12, so now I'm going to do the opposite and add it, the inverse. Add that same number to both sides. Now I'm ready to figure out what I have. Remember, subtracting 12 and adding 12 makes 0, so I don't have to worry about the 12 anymore. I just have x over 3. And then on the right-hand side, I had 6, and I added 12, so that makes 18. So now I'm ready. Now I'm ready to go ahead and get rid of the best friend, that 3. I was dividing that 3, so now I'm going to multiply by that number on both sides. And the reason that I can multiply by 3 is because I'm using one of my properties here. This is the inverse property of multiplication, because remember, multiplying by 3 is the same as multiplying by 3 over 1. Those 3's are going to cancel each other out, so I get 1, but also the x that's still left over. And now I'm ready to get my answer from 18 times 3. Well, it turns out that 18 times 3 is the same thing as 54. So I'm going to write that on the right-hand side. And you can tell that for every single step that I've written, I've got something written on both sides of my equation, and that's very, very important. You want to keep your equation balanced the entire time. So now I know that x equals 54. Let's check that. Let's use that checking strategy that I talked about in the last problem. If I put 54 in for x in my original problem, I should get 6. So I'm going to try to check this. Well, I need to divide before I subtract, so 54 divided by 3 gives me 18, minus 12 equals 6, 6 equals 6. So I know that I have a correct solution here. Alright, now we've got another one that's a little bit tricky. This is 5 minus x equals negative 10. Now this one looks different because my x is my second term in my equation. And I don't really like that. I like when my x comes first. So the first thing I'm going to do is rewrite my problem so that my x is out front. Now this is a subtraction problem. I'm not allowed to just rearrange subtraction problems. I have to change it to an addition problem first. So I'm going to use that rule back from when we were solving with integers, and I'm going to add the opposite. So I'm going to write down the exact same first number plus the opposite of the second number, which would be negative x, equals negative 10. And now that it's an addition problem, I can go ahead and rearrange so that I have negative x out front plus 5 equals negative 10. So now that I've rearranged, I'm ready to go ahead and start solving. I'm going to find that variable and go ahead and circle it, draw my railroad tracks. And first I want to get rid of that addition or subtraction, or that normal, regular old friend. So I'm going to get rid of this adding 5. I'm going to do the opposite, so I'm going to subtract 5 from both sides. And that's going to leave me with negative x equals negative 15. But I still don't have x alone. I have this negative out front. Now this is just a little trick. When I have a negative out front of my variable, I like to go ahead and write in the number 1. because negative x is the same thing as having one negative x. So I'm going to write out that ghost 1, and now I can see that it's getting multiplied by negative 1. To get rid of multiplication, I'm going to divide by negative 1, do it on both sides, and that's going to leave me with x equals a positive 15. Let's see if that goes back into my equation. It would make a good solution. So I had 5 first. Then I need to subtract whatever I found was x. I found that x equals 15. And I want to check if it equals negative 10. Well, 5 minus 15, I don't like to subtract, so I'm going to add the opposite. And now 5 plus a negative 15 is negative 10, which is what I should have gotten, so I know that I have a good solution here. Alright, here's another example. I have a fraction here, so it's a little bit tricky. I have 2/5 x minus 3 equals 7. Well, I have my x out front, so I don't have to worry about that like the last problem. I'm going to go ahead and circle my variable. That's what I want to keep. My 2/5 is closer, so that's my best friend. So I'm going to get rid of the normal friend first. So I'm going to add, to get rid of that subtraction, I'm going to add 3 to both sides. So I'm going to have 2/5 x left over on the left. And then 7 plus 3 will give me 10 on the right-hand side. Now to get a fraction, to get rid of that fraction, we are going to multiply by what we call the reciprocal. And the reciprocal of 2/5 is 5 halves. So I just flip that fraction upside down. So when I'm showing my work here, I'm going to write it out to the side because we multiply fractions going to side, not up and down usually. So I'm going to put 5 on top, 2 on the bottom. I'm going to do that on the other side as well. Put my 5 on top and my 2 on the bottom. And now I'm ready to go ahead and start solving. Well, my 5's here will cancel out. 5 divided by 5 is 1. 2 divided by 2 is 1. So I'm left with just x. And then I need to multiply 10 times 5 halves. Well, an easy way to do that is to put a 1 underneath that 10 so it becomes a fraction. Now I'm going to do 10 times 5 is 50. 2 times 1 is 2. And I can reduce that to be 25. So now I'm going to go back, make sure that it works. I'm going to put 2/5 and then 25 in for x. And I should get 7 when I solve this out. Well, just like we did with the 10, I'm going to put a 1 on the bottom of that 25. 2 times 25 is 50. 5 times 1 is 5. 50 divided by 5 is 10, minus 3 equals 7. So I have a good solution here. On the back of your note sheet, we have some examples that you can go ahead and try using the front as a guide. Make sure you go back to your notes if you get stuck.